Hello, my name is Venkat Maduri, and for this technical presentation, I'll be going over the point class in Java. A point represents a location by using the x and y coordinate plane. It is represented by using integers. The point class is part of the java.object package. It extends the class java.awt.geom.point2d. This class implements serializable. This class also extends point2d. Now for the fields of the point class, it takes two fields, x for the x coordinate and y for the y coordinate. These fields are of int type. Now for the point constructors, the default constructor for point is simply point. The other two constructors that take arguments are point int x, int and int y, basically the coordinates, and point p, the point object. Now for the live code demo, I will be showing three examples in this live code demo that use the point class. Each example which will have its own Java file. It's important to note that I will not be hard coding the entire thing because of time reasons, but I will be explaining the code and I will be running the code and making minor changes to show how the code works. The first example is getting points. The second example is figuring out whether 2 points are equal. And the third example is finding the distance between 2 points. All right, now onto the code. Here we have the name of the class, right here at pointDemo1, and the main method, and the import statement. This is very important to have because without this import statement, import java.awt.point, whatever you do with points will not work. This format will be used for every example. All right, now on to the main method, or the main meat of the example. Here is a point object called myPoint. The coordinates are 10, 15. In these two system.out print statements, the first one prints out the x coordinate by saying myPoint, the name of the myPoint object, dot get capital X. This should get 10. And right here should get the y coordinate. The y coordinate is myPoint.get capital Y. Should get the y coordinate, 15. All right. Let's compile it. No errors. Let's run it. The x coordinate is 10. The y coordinate is 15. Works beautifully. All right. Very simple. On to the next example. All right. Now for a bit more complex one. Here is the name of the point object. The first point object is called myPoint, and the coordinates are 10, 15. The second point object is called mySecondPoint, and the coordinates are 10, 15. Now, here is the if logic. If myPoint dot equals mySecondPoint, it should print out they are equal. If it doesn't, then they are not equal. Let's compile it. Run it. And what do you know? They're equal. Let's change this point, the mySecondPoint y coordinate, to 14. Let's run it. They are not equal. But it's always important to use the dot equals when you're dealing with points. Let's see what happens if we try to do the double equals sign. And let's see, let's put 15. All right, both of these points are the same now. We remove the change. And this time, I'm going to use the double equals sign now. Is it going to compile? It compiles, but let's see what runs. It prints they are not equal, but it should print they are equal. That's because you shouldn't use double equals. When dealing with points, like strings, you use dot equals, but this time when you're dealing with points, you're supposed to use dot equals in order for it to work. Dot equals. All right, compile, run. They are equal. All right, on to the next example. All right, for this example, I'll find the distance between 2 points. Right here is this variable, double distance. I will use this variable to store the distance. And these are the 2 points that I will use to figure out the distance between. Here's the coordinates 10, 20, and the other coordinates 30, 20. Now, without doing any whole work, it's pretty easy to figure out the distance. It's going to be 20. But how do we use code? By using, first of all, you're going to use the Pythagorean theorem formula. In code, you first have to find the dx and dy. Dx is found by subtracting the second point by doing second point minus first point x. Second point x minus first point x. So we're going to do right here 30 minus 10. And for dy, we're going to do 20 minus 20. So this should be 20 and this should be 0. And then we're going to square both of them and add them together. So 20 squared plus 0 should be 400. And squaring 400 should be 20. The distance is 20. Let's see if that formula works. The distance is 20. What do you know? Let's try 40. It should print out 30. I'm sorry, it should print out 30 if I said 40. And what do you know? The distance is 30. Well, that's all I will show for this Techno presentation. There are more things you can do with points and more complex things and more creative things, but those are the basic things that you really need to know when starting with points. Here are some websites for points. This website goes more in depth about points. And this website talks about the Point 2D class. Okay, that's all for this presentation. I hope you enjoyed this and learned something. Thank you so much for watching.